Hi, my name is Sundar Raghavan. I'm a Senior Database Specialist Solutions Architect with AWS. Today, I'm here to talk about how you can integrate existing database resource authorization with AWS IAM and Amazon RDS Proxy to achieve a centralized authorization management model. Before getting to know more about the solution and a small demo, let's look at the services that is involved in this. To begin with, Amazon RDS. RDS is one of the first AWS services launched back in 2009. We have more than a decade of experience operating and scaling database workloads for customers in the cloud. Amazon RDS takes over many of the difficult and tedious management tasks of a relational database such as OS patching, hardware maintenance, setting up and provisioning, encrypting the data at rest in transit, backing up the database on a regular basis, setting up notification, setting up replication, high availability across availability zone or region, scaling up or down a database in alignment with the demand of your application. It frees you to focus on your application so you can give them the fast performance, high availability, and security and compatibility that they need. As customers move more and more workload to the cloud and cloud native databases, it also brings new challenge. With the ability to scale quickly also adds complexity. Especially modern event-based applications such as those built with a serverless or event-driven architecture, which could result in hundreds or even thousands of connections to the database. It also equally true for properly architected, more traditional applications which can open and close thousands of connections simultaneously or simply keep the connections open for extended periods of time. Relational databases have a finite amount of resources, namely CPU, memory, and open and closing of the connections takes resources, especially when connections are at scale. It's not ideal to utilize these resources for connection setup and teardown. Instead, we could rather focus on running queries to serve your end users. Moreover, as the count of database connections increases, the free memory available for OS cache goes down. This causes the OS to remove data pages or blocks from the cache. The next lookup of these pages results in a fetch from the storage volume and is thus therefore slower. If the instance is low on free memory, it starts using the swap space, which is again on the storage volume, and therefore it's going to be slow. This is where the database proxies come into help. So how a database proxy is addressing this issue? A database proxy can create pool of DB connections to the database, and then utilize this pool to communicate with the database through a smaller and more manageable number of connections. It's a software that could be installed on EC2 machine and managed. However, a self-managed proxy can require quite a bit of heavy lifting, including having to deploy it across multiple AZs, scaling it, patching it, maintenance policies, etc. Also, the connection pooler would become a single point of failure. This is where managed proxy come into picture. RDS Proxy is a fully managed, highly available, and easy to use database proxy feature of RDS that enables your applications to improve scalability by pooling and sharing database connections. It also improves availability by reducing database failover times by up to 66% and preserving application connections during this failover. Also, it improves security by optionally enforcing AWS IAM authentication to database and securely storing credentials in AWS Secrets Manager. Note that Amazon RDS Proxy is now generally available for Aurora MySQL, Aurora Postgres, RDS MySQL, and RDS Postgres. RDS Proxy transforms your approach to building modern serverless applications that leverage the power and simplicity of relational databases. First, RDS Proxy enables serverless applications to scale efficiently by pooling and reusing database connections. Second, with RDS Proxy, you no longer need to handle database credentials in your Lambda code. You can use the IAM execution role associated with your Lambda functions to authenticate with RDS Proxy and your database. Third, you don't need to manage any new infrastructure or code to utilize the full potential of serverless applications backed by relational databases. RDS Proxy is fully managed. It is right size based on the application demand. So how RDS Proxy works? Each proxy handles connections to a single RDS database instance or Aurora database cluster. RDS Proxy handles the network traffic between the client application and the database. It does so in an active way, first by understanding the database protocol. It then adjusts its behavior based on the SQL operations from your application and then results set from the database. The connections that a proxy keeps open and available for your database application to use forms the connection pool. RDS Proxy makes applications more resilient to the database failures by automatically connecting to a standby database instance while preserving application connections. RDS Proxy uses the existing RDS security mechanisms such as SSL and AWS Identity and Access Management. RDS Proxy can act as an additional layer of security between client applications and the underlying database. For example, you can connect to the proxy using TLS 1.2 even if the underlying database instance supports only TLS 1 or 1.1. A proxy has a default endpoint. You connect to this endpoint when you work with the RDS database instance or Aurora database cluster, instead of connecting to the read or write endpoint that connects directly to the instance or cluster. The special purpose endpoint for an Aurora cluster is still available. So what are the benefits of using an RDS proxy endpoint? You can use multiple endpoints with a proxy to monitor and troubleshoot connections from different applications independently. You can use reader endpoints with Aurora database clusters to improve read scalability and high availability for your query-intensive applications. You can use a cross VPC endpoints to allow access to databases in one VPC from resources such as an Amazon EC2 instance in a different VPC. Also, working with an RDS proxy endpoints involves the same kind of procedure as with Aurora database clusters and reader endpoints and RDS instance endpoints. By default, the endpoints that you connect to when you use RDS proxy with an Aurora cluster has a read-write capability. As a consequence, this endpoint sends all requests to the writer instance of the cluster, and all of those connections count against a max underscore connections value of the writer instance. If your proxy is associated with an Aurora database cluster, you can create additional read, write, or read-only endpoints for that proxy. You can use the read-only endpoints with your proxy for read-only queries, the same way that you use a reader endpoint for an Aurora provision cluster. Doing so helps you to take advantage of the read scalability of an Aurora cluster with one or more readers in the Aurora cluster. You can run more simultaneous queries and make more simultaneous connections by using the read-only endpoint and adding more reader DB instance to your Aurora cluster as needed. There are some limitations with proxy endpoints as well that you might want to be aware of. Each proxy has a default endpoint that you can modify but not create or delete. The maximum number of user-defined endpoints for a proxy is 20. Thus, a proxy can have up to 21 endpoints. The default endpoints plus 20 that you can create. When you associate additional endpoints with a proxy, RDS proxy automatically determines which DB instances in your cluster to use for each endpoint. Let's look at some concept about the connection pooling in RDS proxy. The connections that a proxy keeps open and available for your database application to use make up the connection pool. By default, RDS proxy can reuse a connection after each transaction in your session. This transaction level reuse is called multiplexing. When RDS proxy temporarily removes a connection from the connection pool to reuse it, that operation is called borrowing a connection. When it is safe to do so, RDS proxy returns that connection to the connection pool. In some cases, RDS proxy can't be sure that it is safe to reuse a database connection outside the current session. In these cases, it keeps that session on the same connection until the session ends. This fallback behavior is called pinning. Each proxy performs connection pooling for the writer instance of its associated RDS or Aurora database. Connection pooling is an optimization that reduces the overhead associated with opening and closing connections and with keeping many connections open simultaneously. This overhead includes memory needed to handle each new connection. It also involves CPU overhead to close each connection and open a new connection, such as TLS, SSL handshaking, authentication, negotiating capabilities, and so on. Connection pooling simplifies your application logic. You don't need to write application code to minimize the number of simultaneous open connections. Each proxy also performs connection multiplexing, also known as connection reuse. With multiplexing, RDS proxy perform all the operations for a transaction using one underlying database connection, then can use a different connection for the next transaction. You can open many simultaneous connections to the proxy, and the proxy keeps a smaller number of connections open to the database instance of the cluster. Doing so further minimizes the memory overhead for connections on the database server. This technique also reduces the chances of too many connections errors. As I mentioned before, here's the reference architecture for having the client and the proxy along with the database in a different VPC. Your RDS proxy must be in the same VPC as the database. The proxy cannot be publicly accessible, although the database can be. So for Aurora database clusters, you can enable cross VPC access by creating an additional endpoint for a proxy and specifying different VPC, subnets, and security groups with that endpoint. Keep in mind, you cannot use RDS proxy with a VPC that has dedicated tenancy. So the next service that I'll be using in the demo is AWS Identity and Access Management. RDS Proxy supports IAM-based authentication to offload credential management from applications. Instead of specifying a username and password while establishing connections, you can use an IAM execution role associated with your Lambda function or EC2 instance to authenticate RDS Proxy. RDS Proxy also allows you to enforce IAM authentication to help improve the security posture of your application. Database credentials used by the RDS Proxy in turn are stored in AWS Secrets Manager. Alternatively, you can connect with RDS Proxy the same way you connect with your database. The username and password you supply for establishing connections with RDS Proxy are matched with the credentials stored in the Secrets Manager and then utilized for creating connections to the underlying database. Authentication is achieved by obtaining a temporary token which is valid for 15 minutes. When it comes to RDS or Aurora Postgres, the connection per second is limited by the type of database instance that you are using. So the next service is AWS Secrets Manager. What is AWS Secrets Manager? AWS Secrets Manager is a secrets management service that helps you protect access to your applications, services, and IT resources. Using Secrets Manager, you can secure and manage secrets used to access resources in the AWS cloud, on third-party services, and on-premises. Answers to the questions such as these lies with the lifecycle management of the secret, which is provided by the Secrets Manager. You can encrypt secrets at rest to reduce the likelihood of unauthorized users viewing sensitive information. To retrieve secrets, you simply replace the secrets in plain text in your application with code to pull in these secrets programmatically using Secrets Manager's API. You use AWS IAM policies to control which users and applications can access these secrets. You can rotate password on a schedule or on demand for supported database types hosted on AWS without a risk of impacting application. You can extend this functionality to rotate other secrets such as passwords for Oracle database hosted on Amazon EC2 or OAuth refresh tokens by modifying sample Lambda functions. You can also audit and monitor secrets because Secrets Manager integrates with AWS CloudTrail, Amazon CloudWatch, and Amazon SNS. You can manage secrets such as database credentials, on-premise resource credentials, SaaS applications credentials, third-party APIs, and SSH keys. Secret Manager enables you to store a JSON document which allows you to manage any text blurb that is 64 kilobytes or smaller. You can natively rotate credentials for RDS, Amazon Document DB, Amazon Redshift, Redis auth tokens for Elasticache, admin credentials for Active Directory. Let's now look at how authorizations work in Postgres. PostgreSQL is one of the most popular open source relational database systems. With more than 30 years of development work, Postgres has proven to be a highly reliable and robust database that can handle a large number of complicated data workloads. With Postgres, you can create users and roles with granular access and permissions. The new user or role must be selectively granted the required permissions for each object. This gives a lot of power to the end user. So we put together a demo and then we'll walk through this demo scenario and then explain how this could be achieved. So here is a model where we have some scenario like this. We have a Postgres instance where we have two different databases, management database and finance database, under which you have multiple schema. So the schema is more of a soft definition in Postgres where it's more like a search path, under which you have multiple tables residing. Across the board, across the database, you have users or roles who have access to these databases. So this is a sample Postgres authentication authorization model which we are going to use. And I'll be showing a demo for this in a while, but this is how at the high level it's going to look. It's going to integrate with IAM identity and access management to achieve that centralized authorization model. So here's a scenario, 4 different scenarios we are going to address. So the first scenario is about native authentication to the database through Lambda. So you have, let's say, as an application that issues call to the Lambda through API, and the Lambda is going to call the secrets manager to get the password and log into the database and does something. The second scenario is about IAM authentication with IAM enabled at the database site through Lambda. So the users will come, and because they're going to assume a role and take a role from the IAM authentication, and with the role, they'll be able to access the database through the Lambda. The third scenario is where we are bringing in the RDS proxy in this case. It's a native authentication where it retrieves the password from the secrets manager, but through the RDS proxy, this Lambda will connect to the database and retrieves the information. And finally, IAM authentications and secrets manager with proxy. And this is where we are going to show you how the centralized authorization is going to come into play. So if you have to explain this to diagrams, here is the high level picture. So you have 4 different scenarios. The first one is a IAM authentication with the Lambda and then directly accessing the database, the first use case. Second is a native authentication, retrieves the password from the secrets manager and connects to the database. Third one is a secrets manager getting the password and connecting to the database through the RDS proxy. And finally, this is a place where you have multiple users to set up users with appropriate role. They can access the RDS proxy, and because RDS proxy has access to the database with the secrets manager properly defined, and these roles will allow them to connect to the appropriate database. We'll also show a demo of a rogue user, meaning a user from the finance user trying to access the database and see how it would end up in a permission denied state. So to set this demo, we have to create certain roles, 2 set of roles, I would say. So the first role we created in this demo is to allow the role assumed by the proxy to have access to the secrets manager. This is where the password is stored. This is what I meant by when I say that you have a secret stored, but it's not just encrypted at rest and transit, but you can also define roles who have access to the secrets. And this is how we control. So the RDS proxy defined here have access to the secrets manager and you can access it. And here are the set of roles Lambda will assume so that they will be able to have access to the secrets manager. So in cases where the Lambda Access Secrets Manager connects to the database, and it does the same thing. So with this, we will show you the demo now, and then we'll walk through that, and then we'll come back and then have some more points we can discuss about the value of integrating all these three services together and end up getting a centralized authorization model. So as you can see in when I was explaining the demo scenario, there are several moving parts. So what I did was I put together a script to create all the components needed for the demo, and then I had them with a configuration file. So I have a script and then also a configuration file. So let's look at the configuration file first. This takes several input, and then you could pass it as a parameter, and then I have it as a script. But in my case, I just have to pass the database subnet group where the database will be created with all the details. So I run the script, and it will show me what it is going to do. I will say that take it from the environment. I have the AWS configure command run, and then it has the environment set there. And then when I do this, it talks about all the resources this is going to create. So this is obviously going to create an RDS instance and then followed by the two proxies. The reason why this script creates two proxies is because we have a set of users connecting to the database through the username password stored in the secrets manager. And there's a set of connections that's going through the proxy. A proxy cannot have both. You can have either this IAM authentication or to the password secrets manager. So even though the database is the same, you need to have two different proxies to accommodate that. You could connect to the database directly if you want, but we are trying to avoid connecting to the database directly. That's the whole purpose here. And then we have secrets manager secrets. I create one to take the master password when I create the RDS instance. The rest of them are all the user that is going to be used to connect to the database by various means, like I mentioned before. Then we have roles that I mentioned before. So these are the roles. Um, so two roles that will allow the RDS proxy to access a secret manager, and also the roles that are needed for the Lambda function to access the secrets manager. And then also followed by Lambda functions. So one for the directly connecting to the database that will access the secrets manager, and one directly connecting to the database using the IAM, and then the rest are for connecting to the proxy directly database using the secrets manager, and the rest are the one that we are interested in, which is a set of users, two set of users, IAM users connecting to through the proxy to the database, and it will be directed to the appropriate database. There's also one extra Lambda functions that I will show you that how when you crisscross, especially when a finance department user is connecting to the management database, then it will throw an error. We'll also show this through the PL/SQL and P/SQL, and then show how it works. So let's first create the necessary resources needed for the demo. So I'll say continue, and then take it from the environment configuration file. So it's creating all the necessary resources. So we'll pause it for a while, and then once everything is done, then I'll show the screen. So the database instance creation is completed, and it also completed the rest of the stuff. So it created, and then we have the database instance created here, and also it proceeded with the creation of the database objects, which will be used for the testing. So for example, it created a test database, it created management and finance database, and then it also created the users that have the privilege to connect to these database at the database level, and then some objects within this each of this database. Then it went on to create the RDS proxy and the necessary secrets that we talked about, and also the roles, and then all the lambdas that are going to be used for testing. So now let's run through each of the scenario and show you how it connects and then what it does, and also corresponding lambda that will do the same thing. Let's also go through the console and then see what objects it created. So it created this instance and it created two proxies that I mentioned, a bunch of lambdas that I will go through and then test these. And then the secrets manager that I mentioned, the secrets actually. The first one is a temporary, the call is temporary because that's where I picked up the master user password for the database. So that will not be used in the demo. So, and then all the roles that are needed for Lambda and for the proxy as well. So these are the Lambdas that got created by the script. So let's go through each of these Lambda and then see what it does and how it connects to the database. So to start with, scenario number one, which is this, where the Lambda connects to the database after getting a temporary password from the IAM. The Lambda that corresponds to this scenario one is this. So let's open this Lambda and then we'll do a test execution of this. So to create a test execution of this Lambda, then we need to add something, a test case. And then here, this is how you create a test. And then I just created a temporary test here. So before we run, we'll quickly look into the permission it has. So the way the IAM authentication to the database is going to work is that for this particular Lambda, this Lambda has a role, and then the role will allow this Lambda to communicate to the proxy or to the database and get the permission and secrets and connect to the database. So the permission is given in the form of a role, and that role is called Lambda IAM direct role. And then if we click this, and it will open up the role, what role it is, and then let's see the policy that role has. This role has connecting allow the effect of allow, and it connects to this RDS instance, and the DB user is this database. This is the DB ID, and then this is the database user. So that's how the permission is established, and that's how it goes and connects to this. So if I go and run this connection, sorry, the Lambda script. So it ran the Lambda script and then it connects to this database. This is the RDS Postgres database endpoint and connects to the user DB user X. And this is the query that it just executed, and then it came out with the result. And that's how the Lambda execution can be tracked, and then it can be displayed here in the console. Now let's look at the scenario number two, which is this, where the Lambda actually connects to the database after getting the password from the secrets manager and then directly connects to the database with the database user. And let's see how this Lambda functions there. The Lambda that corresponds to this scenario number two is this one. So let's open this up. And then as we did before, I also created another test here, and I'm going to run this test. But prior to the test, let's look at the permission. This has a role called Lambda native direct role. And if I open this up, and it will tell you it has a policy that's called native direct policy. And then by expanding the policy and looking at the JSON, it essentially has access to the secrets manager where it can retrieve the secrets for that database user. And that's how it's going to connect to the database, because the rest of the connection information are specified in the Lambda itself. So essentially all it needs is that get the password for the user and connects to the database. So let's go and run this test. And it ran this, and then it actually connects to the database instance, RDS instance, and as a native user, and then it connected to the database called test. That's it, just simple, straightforward connection. Now let's look at the scenario number three, which is this, where the Lambda retrieves the secret from the secrets manager and connects to the RDS proxy, and then which in turn connects to the database. So it's the same Lambda connection from the secrets manager, but instead of connecting to the database directly, it connects through the proxy. So let's see the Lambda, how it functions there. So the Lambda that corresponds to this is the Lambda native proxy. So let's pick this up. And then let's take a look at the permission, what it does. So here, this has a role called Lambda native proxy role. By opening this up, and we can see the policy that it has a permission to retrieve the secrets manager password for the native user the same way. But the way it connects to the database is where the difference is. Instead of connecting to the database, it will connect to the RDS proxy. So same way, so we go and run the test. It ran successfully. So let's go and look at what it does. So it's connecting to the endpoint, which is the RDS proxy, and as a database user, native user. And then it just selects this simple query there. So you can see this one. So now let's see how things are different with the scenario number 4, which is this, where we have different Lambda functions with the appropriate role. It will go and get the token from the IAM, and with that ability to generate the token, and it goes connects to the RDS proxy, but RDS proxy in turn, which has the information about the database, and it connects to the database through the secrets manager. And let's again show this whole functioning of this particular Lambda through the console. Let's look at one example for each. So let's look at this Lambda IAM Proxy Management User 1. So if I open this up, again, I need to create a test event and then run the test and then do this. But before that, let's quickly take a look at the permission. And this has a role called Lambda IAM Proxy Management role. And then looking at the permission for this role, and it has a policy where, as you can see, it does allow the connect to the RDS instance. However, here it is connecting to the proxy, and it is allowed to connect only as a management user. So if with this role, if it tries to connect to a different user, database user, then it will not be allowed. And this policy is what is controlling that. So let's go and run this Lambda, test it, and you can see this. And here you can see that. So it connects to this proxy with the management user as a username, and it gets the database name, and this query is successful. Similarly, I'm going to run one from the proxy finance user. So if I go here and then just again run this, you will see the same result. It will connect to the finance database. And how it happens, because if I go and look at the role, and the role here is fin role, and by looking at the fin role, this role will allow connection. And by looking at the policy, you'll see that it allows the connection to the proxy, but only to the finance user here. So this is where this filtered. Now with this setup, I want to show a Lambda which crosses from management to the finance, meaning a rogue user from the finance, somehow it got this role and then it tries to connect to the, he wrote the function, he or she, and then it connects to the management database. And then let's see what happens. Now, if you open this and looking at the permission, and then this is finance role, finance user, and looking at the definition of the policy, it has only access to the finance user. But if the code is written in such a way that it tries to connect to the management database. So let's go and run this test. This is expected to fail, and it will fail with a permission error. And as you can see, yes, it failed. So it tries to connect to the management and it says that insufficient privilege. And that's how this permission gets filtered. So as you can see that it's trying to connect to the proxy, but it's with a user fin user, but it's trying to access the finance database, and that's where the problem is. So this is how the permissions are managed using the IAM authentication and IAM authorization. So here we played with Lambda and then we gave the role to the Lambda. So that role could be given to an IAM user or an EC2 role. So it can be assigned to an EC2. So you can have a bunch of machine that has EC2 role. So only that machine can only access management database. Or if you have IAM user, then the set of IAM users, then those users can only connect to the corresponding finance or management database. And that's how you can manage the centralized authorization. As you observed in this demo, I've taken the authorization of database resources that exist within the database and integrated with externally with IAM. And that way I can control the authorization of database resources from outside. With this, I'm concluding this demo. Hope you really enjoyed it. Happy cloud computing.